Greetings and welcome to the Introduction to Astronomy. In this week's exploration of the solar system, we are going to talk about the Lunar Reconnaissance Orbiter and look at its study of our closest neighbor in space, our moon. So, the Lunar Reconnaissance Orbiter, or LRO, is one of the most important robotic missions ever launched to study our moon. It was launched by NASA on June 18th of 2009 and achieved lunar orbit on June 23rd of 2009. The LRO was designed to study the moon in greater detail than any previous mission and to provide critical data for future human and robotic exploration. By orbiting the moon at a low altitude and using powerful suite of instruments, the LRO has transformed our understanding of the lunar surface, environment, and resources. LRO was built with two main goals in mind. First, to create the most detailed images of the moon's surface ever produced. Second, to measure environmental conditions that would affect future astronauts, looking at things like radiation, temperature, and terrain hazards for future landings. Now, in terms of the instruments used, the LRO contained several specialized instruments, each of which was designed to study a specific aspect of the moon. There were high-resolution cameras that allowed scientists to see surface features as small as a meter across. A laser altimeter that maps the moon's topography in 3 dimensions, revealing mountains, craters, and even subtle surface changes. Other instruments measure surface temperatures, detect hydrogen deposits, and analyze radiation levels in lunar orbit. Together, these tools give scientists a comprehensive view of the moon as a dynamic planetary body. So, one of LRO's most significant findings is strong evidence of water ice in permanently shadowed craters near the lunar poles. These regions remain cold enough to preserve ice for billions of years, making them potentially valuable resources for future missions. LRO has also revealed the moon is geologically more complex than previously thought. It discovered fault scarps that indicate the moon is slowly shrinking as it cools, and it identified extremely rugged terrain that could affect landing safety. In addition, the LRO helped to refine the ages of lunar surface features by counting impact craters, improving our understanding of the moon's history and the early solar system. Beyond pure science, LRO plays a crucial role in planning human missions. Its data are used to evaluate landing sites, assess radiation exposure, and identify regions that may contain usable resources like water ice. These contributions are especially important for NASA's Artemis program, which aims to return astronauts to the moon and establish a long-term human presence. So let's go ahead and finish up with our conclusions here. And the Lunar Reconnaissance Orbiter has shown that the moon is not just a familiar neighbor, but a world with a complex geology. More than a decade after launch, the LRO continues to provide data that shape the future of lunar exploration and deepen our understanding of the solar system. So that concludes this week's exploration of the solar system on the Lunar Reconnaissance Orbiter. We'll be back again next week for another exploration of the solar system video. So until then, have a great day, everyone, and I will see you in class.